Now that we've looked at an example of empirical and molecular formulas, we're going to look at an example of how to combine the two. Our problem is to find the molecular formula of a compound of 50.7% carbon, 4.2% hydrogen, and oxygen. The molar mass is 142 grams per mole. Our task is to identify the molecular formula. However, we're not given our empirical formula. Instead, we're given percent composition of carbon and hydrogen and the fact that we have oxygen. We can use this information in order to find our empirical formula. To find the amount of oxygen we need, we're going to add our 50.7% carbon to our 4.2% of hydrogen. This gives us 54.9. This 54.9 we are going to subtract from 100. Which gives us 45.1. This is our percent of oxygen. Now that we have our percent oxygen, pause the video and find the empirical formula for this problem. All right, now let's go over that. Remember that since all percentages come from 100, we can assume that in 100 grams, 50.7 grams are going to be carbon, 4.2 grams are going to be hydrogen, and 45.1 grams are going to be oxygen. We are using these in grams so that we convert to moles by using our molar mass. Starting with carbon, we divide this by the molar mass of carbon. Remember, you can find this amount on your periodic table. And molar mass is grams per 1 mole. Hydrogen will be 4.2 grams divided by its molar mass, which is 1.008 grams. And again, that's grams per 1 mole. Then for oxygen, we will have 45.1 grams divided by its molar mass, 16.00 grams per 1 mole. The amounts we get for this are going to be 4.221, moles carbon, 4.167 moles hydrogen, and 2.819 moles of oxygen. These are decimals, they're not whole numbers. So we need to divide by our smallest amount. Our smallest amount are our moles of oxygen. After we've divided all of those, for carbon, we will get 1.498. For hydrogen, we'll have 1.478. And for oxygen, we will have a nice whole number 1. At this point, remember, we want to multiply by the smallest number that'll give us a whole number. For this, we often use our magic box that we talked about earlier. Looking at our decimal, this rounds very, very closely to 1.5, so that's the number we're going to round to. Here for hydrogen, it's the same thing, so we're going to round to 1.5. Since our decimal is 0.5, we're going to multiply everything by 2. $1.5 times 2 will give us 3, and 1 times 2 gives us 2. These numbers, remember, are going to be our subscripts for their respective elements. 2 for oxygen, 3 for hydrogen, and 3 for carbon, making our empirical formula, which I'm going to abbreviate to EMP, C3H3O2. Step 1, complete. Now we have to find our molecular formula. For this, we take the molar mass that we are given and we divide it by the molar mass of our empirical formula. So, calculate the empirical mass for our empirical formula. Pause the video if you need. Alright, the amount I got for our empirical formula was 71.054. Remember, this is grams per mole. We are dividing our given molar mass by that amount. Our given molar mass is that 142 grams per mole. Note, our units cancel out. After we divide this, we are going to get 1.998. Remember, we need this to be a whole number, and our 0.998 really rounds closely to 2. So we are going to multiply our empirical formula by 2. This will give us C6H6O4. This is our molecular formula.